All right, everybody, we are live and let's start off officially with today's lecture. So, today we are going to be studying something very, very interesting. So, yesterday we ended our class with some past paper questions and we were basically discussing the concept of how we can represent negative numbers, right? But today we are basically going to we are done with this, right? Till this very moment, our syllabus had three parts. We had 1.1, which was discussing binary numbers and all those stuff, and then we had 1.2, which was more about these negative numbers and positive hexa and all that. And now we are going to be discussing 1.3, which is basically more of how your keyboard and your computer understands how when we press the M button, the computer gets to know that Mars, let's say, press the character M. So we are going to be studying about characters and keyboards and these text, sound, and images. So the subset or the subtopic which we are going to be studying today is the text, sound, images. Sound, and finally images. That's the name of our subtopic. So the first thing which you all need to understand, let me just enlarge this a bit so that it's much more clear. So the very first thing you need to understand, just like we talked about the conventional number system previously, we said that computer doesn't understand maybe like 75 out of 100. If I say that Manal, let's say, scored 75 out of 100 on a test, the computer won't understand this. What does the computer do? Computer converts it into what? Binary. So it converts it into binary, and then the computer understands 011011101 or something which is exactly the identical form for this very specific number. Now the computer understands this. But let's say, as of now, we were talking about numbers. But let's assume, what if I want to say that I scored 70, 75 out of 100. Now, just like the above example, do you think the computer will be able to understand 75 out of 100 in this English wording system? No, it won't, because we have to convert it into what? We need to convert it into binary. But now in our course, we won't be learning how you convert letters into binary, but we need to understand the basic concept behind how the computer understands that 75 out of 100 will be written in a number like maybe 00111, something like 111000111. Now this concept comes under the section text, the very first thing which we'll be studying. Now what happens is that software developers developed something known as the character set. Character set. I'll be giving the important definitions later on, which you guys have to memorize. In the theoretical paper of computer science, there is this small thing that there are a few a few keywords which you need to memorize. Character set is one of it. In the May, June, I guess in the specimen paper, if I'm not wrong, in the specimen paper, specimen of 2023 paper, they clearly mentioned that write a definition for character set. Now, what's a character set? A character set is basically it's a list. Let me write it up here. It's a list of all the characters, list of all characters and symbols which are represented by a computer. Now, what do we mean by this? Which are represented by a computer. Now, before this, we learned how I can convert maybe 75 into binary. But now it's important to understand that for characters, when we are dealing with character, what's a character? So let me give you guys an example. A is a character, okay? B is a character. C is a character. Wait a minute, I'm getting some messages on. Okay. Manal, is it the same Manal who is taking the class who just messaged me?
Yeah.
Okay, perfect. You will be soon added into the group. Okay, so Abhi, let's focus on the class. So coming to the main point. So A is a character, B is a character, C is a character. Okay, now all of these are different characters. But now let's say I combine them. We have A, B, C. Now, this is not a character. Now, this is what I call a sentence, right? In our casual English, we call this a sentence. But in terms of computer science, we call this string, okay? So you will usually hear the term string when dealing with programming phrases and programming questions. So when we say string, string basically means combination of different characters. Now, when I talk about character set up here, see, we discussed character set. A character set is basically a list of characters and symbols which are represented by a computer. Now, what does this mean? This basically means that the developers, maybe back in a 1990s or something, there was some programmer who might have said that A will have the binary value 110011. Now, this is just an example. You don't have to memorize it or anything, but just get the concept. Okay. So A might be 110011. B might be something like 011010. C might be something like 110010. Now, this basically giving a binary value. Just a moment, let me get a picture for you guys from the internet. It will be much more easy to understand. Character set. Oh, yes, we do have a character set up here. Just a second, guys. Yes, yes. So it's just to give you guys a quick idea. Okay, it's not something जिसको आप लोगों ने याद करना है या anything of that sort, but just to give you guys a bit of a quick introduction into OK. By the way, these notes, the picture is basically from Save My Exams. So आप लोग को पता होना चाहिए. It's really a very good source if you guys want to have a look at notes or any such thing. So it's really helpful. Yep, this is the document. So let me just enlarge it for you. So now look at this, guys. Now what's happening in here? We have A, B, C, D, E, F, G, H. We have the letters, okay? These are the letters. And then I have the equivalent binary to it, right? Look up here. So now if I want to type in A, the programmer has basically told, no, these are not hexadecimal. These are not. The ASCII code is basically something which we are going to be studying later on. Just ignore this for right now. But look at that. We have a letter A, okay? And then the programmer basically told the computer that whenever I type or press the character A on my keyboard, whenever I press A, let's say smaller case, lowercase a, whenever I press the lowercase a, the computer will be given the input of 011000001. Where did I get this number from? Just have a look. This is the equivalent binary. This number is the equivalent binary of the lowercase a. Now, a computer gets this way. Now, when I, let's say, have my keyboard, I have my keyboard, right? So on the keyboard, if I press this smaller a, the computer won't be getting A, but the computer know that this A, let's say this is a button, right? This is your keyboard button. And beneath this button, there is some sort of circuit, okay? There is a circuit, or which you will be learning later on. This is a type of a gate, logic gate, which we call a logic gate. But in simple words, a logic gate is basically a circuit. Now, whenever I press A on my keyboard, what's going to happen? The circuit is going to turn on, and then onto the computer's processor. The processor will get to know that, oh, the circuit has been turned on. It is indicating 011000001. And now it will be executing this instruction, and then onto my monitor. Let's say this is my monitor. Okay, I have this as my monitor. Let me just create a new page, guys. Yeah, so this is my monitor, and now on the monitor, if I'm typing something, maybe this is some app for typing, I get A up here. Now, let's say I type in U. Now, U has a binary. Let's say I press the button U. Now, U will have another circuit under it, and then it will again go to the same processor, and then the processor will say, oh, it's U. What's the binary? It's this, 0110101. And now the computer is going to execute it, and then we will have a U up here. So this is the very basic concept. Let me write this. This is from Save My Exams. A very, very helpful resource for all your subjects, not only CS, for all the resources, Save My Exams. So this table, which has all the relevant binary numbers of all the characters, this is basically known as a character set. So this table, this is, let me write it up here. This is your character set. Now you don't need to memorize the values or the numbers or any such thing, but we have this system which is known as character set. Now, coming to the important part, we have three types of methods to store data. Okay, so we can store characters in three ways. Store characters in three ways. The first method is basically called the ASCII method. ASCII. Now, ASCII basically means American Standard Code of Information, and I don't know what's the last I, but it's something like American Standard Code for Information or something like that. Okay. Now, ASCII is a method of storing data. And what do I mean by ASCII? Like, look up here. All of these digits have some sort of an ASCII code, right? We have a 097 up here, then we have a 101 for E. For the greater E, it's 069. For P, it's 080. For the smaller P, it's 112, and something like that. Now, ASCII is basically the method of storing characters. Okay, it's a method of storing characters, but it's now important to understand that there are some unique characteristics of all these methods which you guys need to understand. The first point about ASCII: whenever ASCII is storing some character, it will be storing it in a 7-bit code. 7-bit code. So this means that if I write the binary 1, 2, 4, 8, 16, 32, 64, this is 7, right? So 1, 2, 3, 4, 5, 6, 7. This is the 7. So the maximum amount of values it can create or store are limited to this register because it can only have a 7-bit code. So the maximum value, like let's say A might be the first element, right? So 1 and the others are going to be 0. Let's say I'm just giving an example. B could be a 2, right? So I can say 0, 0, 0, 0, 0. 2 will be 1 and the other are 0. Just like that, we just created such a big table which goes till Y, Z, and then we also have other characters on the keyboard, right? We have @, we have this hashtag sign, we have the dollar sign, then we have plus, we have minus, we have equals to, we have raised to power, we have asterisk, we have all these other characters and symbols which we also need to tell the computer. Now let's, just for your own question, you can also write emojis now on the keyboard, right? Like maybe if you open your Chrome and you press the Windows plus E button, I guess, or window dot full stop button, you get the emojis tab. And then you can even like make a laughing emoji. Okay, you can make a smiling emoji. You can make like maybe the skull. Usually people do make like something like this is the skull, for instance. But you can make all this. Now, how does the computer get to know this? The computer has already understood that there can be such symbols inputted. Okay, and now how did the computer understand? Through these 3 methods. The first method is known as the ASCII method. Okay, now the ASCII method has 7-bit code. Okay, and it only uses English language. Important fact: it only has the English language characters. So whenever we are dealing with ASCII characters or ASCII code, if the question says ASCII, just the word ASCII, then understand that we are only dealing with English letters. What do I mean by English letter? A to Z, 1 to 9. Okay, and then the other thing is that one other factor or characteristic is that it uses less bits per character when compared to other methods. Now you will get the third point when I discuss the other 2 methods, and then we will discuss what do I mean by the third point. But for now, the 7-bit code basically means that the maximum number of combinations which we can make right now are 64, 32. Just a moment, let me add it: 16, 8, 4, 2, 1, are 127. Like let's say the last number which I want to represent using an ASCII code will be what? 1, 2, 4, 8, 16, 32, 64, 127. So like if I want to, let's say we are going in a sequence 1, 2, 3, 4, 5, 6, 7, 8, and I'm just setting the binary values for all the numbers. The greatest possible number will be what? It will be 64. It will be 1, 2, 1, 1, 1, 1, 1. If I turn on all these values, the greatest range I can get is a 127. This means that ASCII, basic ASCII, can store 127 letters or symbols. But usually the plain ASCII only has letters with it. Okay, because if we go from A to Z, then 1 to 9, and then also capital A to Z and include those important symbols, it is going to take the 127 limit we have. And so one con or one disadvantage of the ASCII system is that it has limited space. Okay, because it only had a 7-bit code. And now let's say we are just talking about English, but do you guys know now in your latest keyboards you can also write Turkish? Okay, you can write Turkish, you can write Urdu, you can write Arabic, you can write Chinese, and all of these other languages. Now, how did the examiners, or sorry, the examiner, how did the programmers come to this discussion that, oh, it's not only English in the world, right? In the China region, we might be using Chinese language. In Pakistan, we might be discussing stuff in Urdu. A lot of people still write messages in Urdu. Like, it's really important to understand that Urdu is also an important language which the computer can should be understanding. But now the issue with ASCII is basically ASCII is that it has limited space. It has that it has is that it has limited range. Why does it have a limited range? Because it has a 7-bit code, right? So it can only have 127 letter. Now let's say 127, 36 capital, 36 lowercase. So you get like 60 of these, then you add the number 70, and maybe 30 of those are the basic symbols, plus, minus, equals to, maybe hashtag, square brackets, and all those other command functions. So 127 fills up immediately. But if I want to include Urdu, maybe only the Urdu language takes an additional 120. Now, where will I be storing that? This was a question which came into the programmer's mind. And so they came up with a new method, which is known as the extended ASCII. Now, this is something different from the original ASCII. Usually, kids don't understand this. In the book, it has been written very, very in less detail, due to which usually kids overlook it. But what's extended ASCII? Now, extended ASCII has the first characteristic as that it has an 8-bit code. 8-bit code rather than the 7-bit which the original ASCII had. Okay, it has 8-bit codes. So if it has 8-bit codes, what does this mean? This means that we can now store 1, 2, 4, 8, first 4, then 16, 32, 64. This was the 7th one, right? This was the 7th one where we stopped for the ASCII, original ASCII. But if we have the 8th one, it also means we have a 128 now. Now this is 8. Now, if I turn on all the bits, 1, 1, 1, 1, 1, 1, 1, what's the answer? I get the answer as 255. Now this means my range has increased. Now let's say it's not only English, but maybe I can also include English plus Chinese. If, for instance, I was given a choice that you can store only 2 keyboard languages, then I would have stored maybe English and Chinese only. Because now we have a greater range, maybe 70 for English, 30 for the characters, 100 for Chinese, maybe 100 for Russian. And so if I add up, I can now store multiple languages. Now, the first point, it has 8-bit code. The second point, extended ASCII, usually it has English only, but we also have non-English symbols. Non-English symbols. What do I mean by non-English symbols? You can include these other languages, maybe Chinese, or like the symbols I mentioned, like maybe a smiling face, or maybe some square brackets, or maybe the hashtag, multiply sign, and all those stuff. Okay, you can have those non-English signs too. And then the third point is that it relatively uses less bits per character. I will explain this. Less bits per character. Again, you will get the third point once we discuss the last form. But for now, understand that we have discussed ASCII, the plain ASCII, which is a 7-bit code. Due to it having a 7-bit code, we have a range of only 127. And so we can only store the English language characters, which are basically A to Z, smaller lowercase, and then A to Z, the larger case. But when you turn to extended ASCII has this additional element to it, that it has an 8-bit code. When I talk about 8-bit code, yes, exactly, Ahmed. You have more space. Now we have this 128 with us too. So if I add 128 into 127, we get 255. Now our range has basically increased. So when our range increases, we can include English, and then we can also have some non-English characters such as Chinese maybe, or some of these letters. And if you have seen maybe on your keyboard, sometimes you can write Z, but if you hold the Z button, what happens is that you get an extra option, like maybe Z like this, and maybe Z like this, and maybe something like Z with a comma. These are basically the characters which are non-English characters, which are maybe, this might be something like Turkish, then this could be something like Russian and stuff like that, because a lot of languages are still written in English form, but it has some sort of additional elements attached to it, just so that it's much more easier. Okay, so now let me continue. Now the third method. The third point is the very important latest technology which is even used nowadays. Now the issue is that if you think 255, do you guys think 255 is still enough in this Gen Z type of world where we have 100 of emojis, 100 of GIF images, like millions of languages, like people are even making their own languages, key codes and stuff like that. Do you think 255 is enough? No, it's not. Exactly, Ahmed. It's not enough. 255 is a very small place. So 255 is very limited. If you assume that, let's say we have how many countries? I believe we have 195 countries. And let's say I want to include the language for even 50 of them, 50 languages. Even if I want to include 50 languages, it's going to take a lot of space, which is not available when we are dealing with 255 characters range. Now, what do we have to do? In this case, the programmers came up with a new system, which they called as the Unicode. Now, the Unicode is basically the latest and it has the highest range, highest range. Now, what happens is that Unicode doesn't operate on some 8-bit code or like a 7-bit code. Rather, it has a range of either 16 bits or it can also go up to 32 bits. So just imagine we were only discussing up to 8. Like just imagine this was 8. Imagine this continues like 9, 10, 11, 12 to a 32 element. It will have like million of possible options. Exactly. Now you can have millions of options. Now in millions of options, you can definitely include the 3790 emojis that are supported by Apple. And then you can also include Urdu, Pashto, English, Turkish, Chinese, Mandarin, Cantonese, Russian, Arabic, and all those other languages. Now, why? Because we have a much greater range with the number of bits we are using. We can use 32 bits, which supports up to hundreds and thousands. And then we can also, if we want to reduce the space, because the more bits you use, the larger space it will be occupying. Now, this was the point basically which I was saying that आप लोग को बाद में समझ आएगी. Now, because it has 16 bits or 32 bits, the plus point is that it can support multiple languages, as well as symbols. By symbols, I usually mean other languages too, because like Chinese might be something written like this, some awkward symbol, right? So, multiple languages and symbols are supported. But there is one disadvantage of Unicode, and that disadvantage is that it uses more bits per character. Per character. Now, if you see, let's say I'm dealing with 32 bits. 32 bits basically mean that if I want to have a binary number, it will have 32 digits like 00001101001, and it will continue till we have 32 digits. 32 digits. But at the same time, if I was just dealing with the plain ASCII, the 7 bits ASCII system, it would have only be 011010117 1 2 3 4 5 6 7. So just see, if I input this number into the computer, and then if I input such a large number which has 32 digits, obviously the one having more bits equals to more space. And so this basically means that when we are dealing with Unicode, it will be occupying more space. So this is really important because Unicode does allow the fact that we can store multiple languages and characters, but there is a catch to it because we are dealing with more number of bits which allow us the greater range. This means that we are occupying a much larger space on our hard disk. And so initially, if let's say I could have written 1000 words using ASCII, for instance, this is just an example. Okay, if I was able to write 1000 words using ASCII, I might be able to write 900 words using ASCII extended. Why? Because ASCII extended has what? It has 8-bit system rather than the 7-bit number system which the ASCII originally had. But using Unicode, I can be only writing maybe 500 words. So you see, I had a lot of great capacity with the ASCII, which I don't have with the Unicode. But still, in nowadays, whatever computer you are using, whatever device you have, we are only working with Unicode. Another element to look up here is that you see Unicode works with 16 or 32 bits. 32 bits basically means 4 bytes. Okay, it means 4 bytes. How did I get to know that 32 bits is equal to 4 bytes? Because it's important that 8 bits is basically 1 byte. 8 bits is basically 1 byte. So if I divide 32 with 8, I'm going to get 4 bytes. So this means if I write a single character, if I write A onto the computer, A, it will be occupying 4 bytes if I'm using what? Unicode. But at the same time, if I was, let's say, dealing with the extended ASCII, which is occupying only 8 bits per word, like you see, I mentioned up here, right? It has an 8-bit code, 8-bit code. Now, if it has an 8-bit code, it will be only occupying what? 1 byte. 1 byte. Why 1 byte? Because 8 bits is equal to 1 byte. So just to give you guys a quick example, if we have to look at ASCII and then if we have to compare it with the extended ASCII, if we have to compare the extended ASCII with the Unicode will be occupying 4 times more space than extended ASCII. Then extended ASCII. Now, these are the three main concepts. Ryan, what did you mean by 32 plus 8? Can you let me know so that I can either re-explain or that if you want to contribute something to the class, I can share it with others too. Now, these are the three main systems. Okay, we have the ASCII, which is basically a 7-bit code. It is a what? It's a 7-bit code. Due to it having 7-bit code, we can only store English language characters, and it uses less bits per character, right? So this is the point which I was trying to explain. Less bits per character means it will be occupying less space in the memory. And due to it only having 7-bit, the maximum letters we can store are what? 127. You don't need to memorize 127 or anything. Just keep this in your mind that this point is important. It has a 7-bit code. And then the other point is that it can only store English language characters and it uses less bits. Usually a question is given as in that, what's the difference between ASCII and extended ASCII? So the answer, one marker, will be that ASCII uses a 7-bit code, whereas extended ASCII uses what? Extended ASCII uses an 8-bit code. Now, why are we using 8-bit code? Because using an 8-bit code allows us to have a greater range. So we can store up to 255 characters, which allows us to also store non-English symbols alongside the English symbols which we already had. So the English symbols are basically just from the ASCII table, which we had previously. But now when we shifted from 7-bit to 8 bits, the positive point is that now we can also store what? Non-English symbols alongside it. But now the last point, uses relatively less bits per character. Now, what do we mean by relatively uses less bits? Relatively uses less bits basically means that if we compare it to ASCII, the original ASCII, it is occupying more space. Yes, it is occupying more space. But if I compare this to the Unicode, it is still occupying 4 times less space, right? Because Unicode occupies 4 times more space than the extended ASCII. So we always say that relatively, the term relative basically means that relative matlab in comparison to something else, it is still less. Even though it has increased, it is occupying more space, but still compared to Unicode, it is occupying way less space. And so we use the term relative. Relative to Unicode, it is still using less bits per character. And then we have the Unicode, which is the latest and the one with the highest range. Why it has the highest range? Because we are dealing with 16 and 32 bits. Dealing with 32 bits allow us to have millions of options. So if you have millions of options and you compare it to the limited 255, where we can barely only store English and some other non-English characters, we can store now multiple languages. You can store multiple languages and symbols. And so they are now supported when we are dealing with Unicode. But the only point which you need to understand is that Unicode uses more bits per characters, and due to which it occupies more space. So occupies more space occupied in the memory, space occupied in the memory. So is this clear till this very point? Yes, more bits, exactly. Is it clear till this very point? Exactly, Ahmed. 32-bit system can represent nearly billions, millions, and billions of numbers. Because just we said, like, हमने बोला ना कि 8-bit is 128, then it's 256, 512, 1024, 2048. Like, the 12-bit is 2048. Just imagine if it continues till the 32nd bit, it's going to have like a million number, right? So it will be a very big number. So because of that, we have a larger number set. So 2 power 32 exactly. So यहाँ तक तो हो गया. We are done with the text. We are done with what? We are done with text. Let's discuss sound. What's sound? Now, there is a word which you guys need to understand firstly. Sound. Let me write up sound up here. So before this, when I used to talk about numbers, right, I used to say the word conventional numbering system. But let's say I want to input something to the computer. I have a microphone up here. This is a microphone, okay? And I connect this microphone to my laptop, okay? I have my laptop up here, laptop. And then I use this for some editing or maybe some class purposes. And then like, let's say I get a video, and then the video I then let's say upload it to the internet. This is the globe, okay? Globe. So I upload it to the internet. But the important thing is, how does a computer, the laptop, understands what I'm trying to say onto the microphone? This is a very important concept which we need to understand. Like, if I'm speaking right now, I'm saying a word like, hello, my name is Maz Munir, and I'm teaching computer science. Now, how does a computer converts my phrasing into binary? Into binary. And how does it understands it? That's the concept which we are going to be studying now. Now, the first thing which you need to understand is that there is a term known as analog data. Analog data. Now, analog data is the data which we are trying to transfer. So like if I say hello, now the computer won't understand hello. Computer only gets zeros and ones, right? So if this hello term, the word hello, this is basically analog data. Analog data is the type of data which we, the humans, physically give to the computer. And once it's converted into binary form, this data is known as what? This is known as the digital data. So digital data and then the analog data. And what happens in between? What is basically the converter of analog to digital data? It is basically your microphone. So your microphone is basically the converter which converts your analog data to the digital data. Now, just a second. Let me get it up here. So now what happens is that you guys are studying physics, right? No, yes, analog to digital converter, and we will be discussing that later on. But for now, this converter, which is usually known as analog to digital converter, we will be studying this later on in chapter number 4. But this converter is basically known as analog to digital converter, or in short form, ADC, analog to digital converter, ADC converter, okay? So your ADC converter or analog to digital converter, in this case is what? It's your microphone. But how do you convert this hello to the number of zeros, 1, 1, 1, 0, and 1? This concept is known as sampling. So whenever I say something, you guys have studied physics. Sound cannot travel, right? If there is no source of what do we call medium in between us. And what's the reason behind it? Because we are talking using sound waves. We have waves. And for waves, we need to have some sort of medium. But now, if I want to convert the sound waves using an ADC so that the computer understands, the method or the mechanism which I will be using is called as sampling. 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 This is the name of the method. Name of method. Now, what happens in sampling is that, let me just get you guys a quick photo, or perhaps let me just make the diagram myself. Just a moment. We have this as a table. या फिर picture ही ले लेता हूँ. Yes, microphone is the only analog to digital converter in this case. Microphone is what? Microphone. Now, microphone is fetching my voice, right? I'm talking about, hey, my name is Maz Munir. Now, the microphone gets this, but the computer doesn't understand why my name is Mohammad Maz Munir, right? So, what does the microphone do? The microphone converts Maz Munir, hey, my name is Maz Munir, into zeros and ones. And then that zeros and ones is something which you guys, with the computer, firstly understand, and then it transfers it to the other side, like onto your devices. And then using your speakers, the number zeros and ones are again converted to the same phrase which I'm trying to speak up here. So let me just take the screenshot from the book because it was really, really easy up here how it works. So let me snipping tool, the new, just a moment. So ऐसा चलता है कुछ. अब तो can I just paste the picture in the chat box? Let me just see if I can, because I use two devices. So no, we can't. So I paste it up here and then I have it up here. Then so let me just open up the WhatsApp from my Mac and फिर यहाँ पे this is the image download. So now look at this image. Let me just paste it from downloads, downloads. WhatsApp. Yes. Guys, look at this. This is basically some sort of graph. Like this is how your computer converts. You guys don't need to know anything, how it's made, anything of that sort. But what happens is that when I speak, I am giving the computer some sound waves. I'm giving the computer what? Some sound waves. And so the microphone gets my waves in such form. It is making such pattern, like something like ooh, ooh. You guys will study this in physics either way, okay? So you will be having such ups and downs. Now what happens is that a computer conducts something called as sampling. In sampling, it is trying to take an average that maybe in time interval 0 and 1, it had an amplitude of maybe 10. Then maybe in time interval 2, it had an amplitude of 3. Maybe at time interval 4, it had an amplitude of 0. So using this, the waves, they try to get some average value for every phrase which I'm speaking. Maybe if I say hi, now the pitch was really high, right? So when the pitch was high, the amplitude is going to stay up to like maybe let's say 10. Now the computer will say, oh, the pitch was high and it had a sound which had something like this. And so it gives me like a wave of this sort. Okay. But then I'm like, hi. Now this high is with the one which really low pitch and really low sound. So it will have something like this, like the 4 up here, or maybe this 3, or maybe this 1, right? So now based on this, the computer gets an average value for every phrase and sound which I'm trying to say. Like the computer doesn't know whether I'm giving some sort of sound, but what's speech? Like if I say what's the definition of speech, what I'm saying, it's basically the combination of different sounds which I'm trying to explain as some characters or letters. But to be honest, these are basically different sounds. Like what's Chinese, what's Urdu, these are simple sounds which I'm combining together, which gives like an impression that I'm trying to speak something. So the computer gets all these sounds, and then what it does is that in sampling, it takes average of each sound, or average of each sound. And then what happens? I get an amplitude, and based on that amplitude, it will be forming some binary number, maybe 11001011, and this might be representing my name Maz. This is the very mechanism which your computer uses to convert your voice into what do we call it? Binary numbers. So sampling is basically used to determine the amplitude of the sound after set intervals. And this gives us an approximate representation of the sound waves. Okay. So what happens, just to give you guys a quick overview, आप बात करते हो, when you speak, the computer hears voices, it hears sounds. And those sounds are in what form? They are in the form of sound waves. When it hears those waves, the microphone basically, it fetches those waves and it forms a graphical representation like this. And then the computer takes average of the amplitude on different intervals. Maybe at 10 seconds, if I take an average, this is up here. But if I go 0.5 down, 0.5 up, maybe I get the average of something like this. And now the average is what? It's a 6. So let's say that 6. And if I convert this 6 into binary, maybe just for instance example, I may write something like this. Now 0110 is what? This is 6, right? This is positive 6. But this is just an example. No need to understand how I'm going to be converting zeros and tens. But let's say now I have 0110, and this might be some sound or maybe some letter like M. M might be having 0110 value. Now, this is how computer basically converts your values into your speech into binary form. Now there are a few definitions which you guys need to understand. Now there is firstly sampling. What is sampling? I will be sharing the exact definition. For now, just understand the concept. Sampling is what? Sampling is this process where we determine the amplitude after set intervals. See, we have set intervals, and then we are determining what? We're determining the amplitude. And we are doing this after set intervals. So this process is known as what? It is the sampling. Then we have some other word which is known as sample rate. This is something which they can clearly ask you to define. What is sample rate? Sample rate is basically the number of samples taken per second. Taken per second. So the number of samples taken per second is called the sample or the sampling rate. Now, the greater number of sample rate you have, the better the quality. Now, let's say maybe if I take only two samples, okay, two samples, and maybe at the first sample, if I speak something, the amplitude is maybe 10. But at the same time, if I was taking maybe at the second sample might have been something like a 6. So if I take the average of 10 and 6, what will be the answer? It might be an 8, right? But if I have four samples, the first one is a 2, maybe. Like, how do you know? Guys, do you know when you're making these music in the studios, what happens is, why is the quality for those studio music like Coke Studio or something like that? Why is the quality so high? The reason behind that is that they are taking multiple samples. Maybe for the guitar, it has 2. Maybe for the piano, it is 10. Maybe for the vocal, the person who is singing, it might be something like a 14, for instance. Now, it will be taking average, and then maybe let's say we have something like some other instrument, maybe drums, and those drums are going to be like a 3. Now, the computer will be taking average of all this, 14, 3, 10, 2, and it will come up with a number that, okay, the ideal average is 9. For the first second, now the sound which the computer got at the first second when the microphone was turned on, it had a volume equivalent to an amplitude of 9. And so it will convert this into some 01011. So this is basically how computer understands कि जब मैं कुछ बोलता हूँ, तो this is how it's converted to your binary form. Okay. And the third definition, again related to sound, is your sampling resolution. People do confuse sampling resolution and sampling rate. But sampling resolution is the number of bits required per sample. Now, sampling resolution is also called bit rate. Bit depth, sorry, my bad. Bit depth. Now, what's sampling resolution? You might be thinking, which one is more important, sampling resolution or the sampling rate? But if you look at this example, what's the largest amount of amplitude I might have? It's 10, right? It's 10. And what's the least? It's 0. So this means our range is from 0 to what? 10. We have a range of 0 to 10. But down here, I give you an example where I had an amplitude of 14. Does this mean that our range is always going to be from 0 to 10? Isn't it possible if I have some sort of a very good instrument, or maybe I have some high quality mic, maybe I get it from for like 50,000 mic or something, will it have the same quality of a microphone which costs 2K? Will 2K mic have same quality as a 20K mic? No, right? There will be a difference. Exactly, Rayan. It won't be same. Why? Now that's the question. Why? The reason behind this is that your 20K mic has a larger what? Sampling resolution. Larger sampling resolution. And what is sampling resolution? Sampling resolution basically means that if I want to store some sound, like the same example, If I have a lower quality mic, maybe some 2000 mic, it might be storing the values in 1248, maybe 4-bit register, 4 bits. So what's the maximum number of sounds it can store? It can store 1111. It can store maximum 15 sounds, right? Maximum, that this is just an example, but it can maximum store 15 word type of sounds. But now let's say I have a mic which supports up to 32 bits. Now, this 32 bits will be able to store millions of sounds, millions of sounds. Now, when I can store millions of sound, this means that on the table, this graphical table, if I'm using a 4-bit one, the maximum amplitude I might be able to have is 4, maybe 4. So it could be 1, 2, 3, 4. And if there is some sound which is having maybe 20, the computer program, because it has a maximum capacity of 4, it will like make a line up here and it will ignore all of these values which are above it. So we won't be dealing with the higher quality. We automatically ourselves are setting a wall up here above which if we have any sound, yes, exactly, coming to the same point. But if we have a line up here above which, even if the quality supports it, we are just going to cut it off. We are going to ignore it, guys. We are going to ignore it. We are only going to be dealing with these 3 to 4 lines because it's within the range. But now, let's say I have a 32-bit one, and the voice, the 4, 5, this might be 12, this might be, and this is 32. Okay, this is 32, whereas this is the same 4 which we had previously. But now this 32 one, see, it has a much larger quality. Definitely, it can now support up to millions of more sounds. But this and this amplitude thingy, like having 4 up here and then a 32 up here, is what a larger sampling resolution allows. Now, when you have a larger sampling resolution, you can have more amplitude, the greater amplitude. And similarly, if you have a large sample rate, which means that you're taking more number of samples per second, it will again ensure that you have a much higher quality. Now, sometimes a question comes, how can I improve the quality of a sound audio? So the very first thing, we usually, when we are talking conventionally, if let's say Osaim asks Rayan that, Rayan, I'm using a microphone for playing Fortnite, but the issue is that my friend, maybe who else is in the class, let me just see, Ahmed. So maybe Ahmed, the person who I'm playing with, Ahmed is wondering that that Ahmed cannot clearly listen to what I'm trying to say. So Rayan, can you please suggest me some good microphone? So Rayan will be like, oh yeah, go get this microphone from this company. It has a very good quality. But then there is someone who has studied computer science. Maybe Manal has studied computer science. And then I asked Manal, can you please suggest me how I can improve the quality of a sound? No, she won't be like saying, oh Maz, get this microphone. Rather, she would be like, when I like, let's say someone asked me that, Maz, I'm planning on buying a computer, I'm not like, go buy this laptop. I always say, get a laptop which at least has 16 GB of RAM, because I know the specification. Now Manal will be saying that, Maz, get a microphone which has a high sampling resolution. Now she could specify something maybe like 32-bit, 64-bit, but high sampling resolution. First point. Then she might be like, get a high microphone which has a high sample rate, high sample rate. Now, when I buy a microphone with a high sample rate and a high sampling resolution, the benefit will be that automatically I get a higher quality. But whenever I'm dealing with a higher quality sound audio, there is a problem with it. As a greater sampling resolution and a greater sampling rate will require large number of bits, right? More bits, large or more bits, because it will be occupying more and larger amount of bits. The issue with this is basically you, okay, is my camera clear? Okay, it's here. So when we are dealing with more or larger number of bits, the issue is that, just as I mentioned previously, if we are dealing with 4 bits, the maximum memory it will occupy on the memory hard disk or hard drive will be this much. But if I have a 32 bits, it's going to be 1 up to the 32 bit, right? Now this will occupy way more space. So the pro point is that we get a higher quality, but the con is that it will occupy more space. And this was told by Rayan, that it occupy more space. Yes, exactly. Larger sampling resolution means more storage, because larger sampling resolution means we are using more number of bits, which allow a much higher quality. And when we are using a much higher quality microphone, we are basically having a larger number of bits, because we are using more bits, and due to which, when we are having larger number of bits, it will be occupying more space, and so our file will be larger. You usually, when you record, if I give a quick example, if I record something, if I watch a YouTube video on 480 pixel, it will be taking less internet rather than if I'm watching something at 2160 pixel, which is basically 4K. If I watch something at 4K, definitely it will be taking much more internet than watching it at daily 480 pixel, because I'm almost spending 5 times more internet power, which I would have used if I was only using the 480 pixel internet. So this is basically the main concept related sound. Exactly, more number of bits. So did you guys understand how the computer converts my speech into binary form and then evaluates or perform functions or whatever thing we want to ask the computer to do? Do you guys got the whole concept, or do you guys want a quick recap on it? अगर जल्दी जल्दी मैं आप लोग को ऊपर से बताऊं, so it's the same thing. We speak in, it goes in as sound waves, then we convert it. And how do we convert it? Using an analog to digital converter, which is microphone in this case. And when we want to convert it, the method known is called sampling. Sampling is the name of method. What happens in sampling? We basically take average of each sound the computer is getting at different intervals. So we have different intervals, 0 to 20 seconds, and then we have different amplitude. So we say, and a graph is made maybe at this point, which is 8 and 7 seconds. Maybe at this I'm getting an amplitude of 9, and so the computer is maybe going to form a binary number or like this, 11001101, which might be denoting the word mass. Okay, and just like that, if I want to, let's say, improve the quality, there are several methods to it. The first thing which is really important is your sample rate. Sample rate is basically the number of samples taken per second. Then if I want to increase the number of samples, this means I'm indirectly improving my quality, because if I use limited samples, maybe the average will be 8. If let's say one sound is denoting 10 and then the other sound is maybe denoting 6, the average will be 8. But let's say if I use 4 samples for each of the other devices I'm using, maybe I have a guitar which is giving me a 2, and then maybe I have some piano which is giving me a 10, and then something like giving me a 14 and a 3. If I take the average, I get a much clearer audio with everything much more balanced in a better way. So I might be getting 9, which will be giving me the same binary but in a much better quality, right? And then lastly, we have a sampling resolution. Now, what sampling resolution, or the word bit depth? Usually examiner do say bit depth. So no, that bit depth and sampling resolution are 100% identical word, and sampling resolution is basically the number of bits which are required per sample. And so if you improve or increase the number of bits you can have, this basically means that rather than having a limit at 4, where if we had something which was greater than 4 bits, we would have ignored it, right? This number will be ignored at this case. But if I have the range up to 32, I can definitely include the bigger elements too, which means I will be having a much more clearer audio. And so if I increase the sample rate and if I also increase the sampling resolution, I will be getting a much higher quality. But the thing is, when I will be using higher quality, I will be storing much more bits. And when I will be dealing with much more bits, I will be occupying more space. So rather than a CD which had a lower sampling resolution, maybe it might have occupied 20 MB. But if I use some studio level microphones and record my audio, it might take something like 170 MB. So this increase in size, despite of the wording being the same, even when you download some audio from the internet, it gives you the options of different qualities. So when you download the one with the greater quality, the main difference is the greater one has more number of bits. When it has more number of bits, it occupies more space, but it has a higher quality. But if you go with the lower one, it will be using a lower sampling resolution, a lower sample rate, due to which it will be using less number of bits, and so it will be occupying less space too. So we are also done with what I told in the very first, sound. We are also done with sound. Now we are only left with images, right? We will be discussing images, inshallah, tomorrow. So images will be done tomorrow. And once we are done with images, we are done with the whole chapter, inshallah. And then we will be doing a few past paper questions. And once we are done with that, we are completed with chapter number 1, and फिर उसके बाद we will start off with chapter number 2. So is this clear? Exactly. They also use soundproof rooms in musical studio. Why? Because when you use, okay, what's the reasoning behind soundproof studios? Now, if I have a soundproof studio and I say something, definitely the quality will be much more higher, right? Because the computer will be better able to fetch my sound, and when it fetches my sound in a better way, this specific, where is the this wave, this wave won't go to like 10. If the sound is clear, it might go up to 20. But if we have this a lower sampling rate, sampling resolution, then it won't do any good, because we will be having a limit at this point, above which if we have something, it will be getting ignored. But if we also have a large amount of sampling resolution, so we would be able to include much greater resolution too. So is this clear, guys? Let me know quickly in the chat. We are done with 2 of the main things. I was planning on doing images too, but कोई नहीं. It's good. आप लोग को अच्छे से clear हो, because usually kids do confuse this small thing. Tomorrow we are going to be talking about how to calculate file size. Then we also have some terminologies, terms, which I would like to discuss with you regarding images. And finally, we always hear the term compression. If I have like a 1 GB file and I want to reduce it, I compress the file. And oh yes, we also forgot the file sizing. So we are also going to be discussing file sizing, and then we are going to be, inshallah, done with the topic. So that's all for today. Let me just turn off the recording. It'll be recording. So if you're watching on YouTube, yeah, you can join our discussion forum, and bye-bye. So